Hey everyone, and welcome. Today we're going to dive into some really game-changing tips that are going to completely transform how you write Python for your AI projects. We're talking about moving from that feeling of frustration to building some seriously high-performance systems.
So let's just start with a really direct question, one that I think hits home for a lot of us. You've got this brilliant AI model, a fantastic idea, but do you ever get that nagging feeling that the code, the Python code itself, is the real bottleneck, that it's the one thing stopping you from hitting that next level?
Well, if you feel that way, you are definitely not alone. This is what I like to call the AI Coder's Challenge. It's that classic story of going from a cool prototype to a really frustrating production reality, where you just keep hitting these unexpected walls. But today, we're going to flip that script.
I mean, does any of this sound familiar? Your data processing is just crawling. You're spending hours, maybe even days, chasing down these mysterious bugs that seem to come from nowhere. Or you look back at code you wrote, just a month ago, and you have no idea what it does. And of course, you just feel like you hit a performance ceiling you can't break through. These are the exact issues we're going to tackle right now.
Okay, so let's kick things off with the absolute foundation of pretty much every single AI project, the data. It's time to start looking at what lies beyond our comfort zone, beyond Pandas, especially when things start to get really big.
Look, we all love Pandas, right? It's like the Swiss Army knife for data science, and for good reason. But, and it's a big but, the moment you scale up to massive data sets, we're talking gigabytes, even terabytes, it can become incredibly slow. And worse, it just eats up all your RAM, basically bringing your entire machine to its knees.
And that brings us to our first hero of the day, Polars. Seriously, you can think of it as Pandas rebuilt for the modern multi-core world. It's written in Rust, which is known for its incredible speed, and it was designed from the ground up to use all of your computer's cores at once. That's the secret sauce.
Now, what's absolutely amazing is how easy it is to switch. Just look at the syntax. On the left, that's your standard Pandas group by. On the right, Polars. It's almost identical. The logic is the same. The only tiny change is how you tell it what to aggregate. For that tiny bit of effort, you are plugging into a completely different, lightning-fast, multi-threaded engine. It is the absolute definition of a small change for a massive win.
So what's the bottom line here? It's simple. You make this one small switch and you get way faster data processing, and you use a fraction of the memory. For any AI project that's heavy on data, this isn't just a nice little optimization, it's a total game changer.
Okay, speed is awesome. We love speed. But what's the point if your code is a total mess? Code is read so much more often than it's written, so for our next section, let's talk about how we can write code that actual humans, including our future selves, can understand. You know the scenario. We've all been there. You're just passing Python dictionaries all over your code base. You look at a function, and you have to ask, wait, what fields are supposed to be in this dictionary? Is the ID a string, or is it an integer? This kind of guessing game leads to super confusing code, and, even worse, those silent, nasty bugs that only pop up when you're running the code for real.
And this is where Pydantic comes in to save the day. It's this incredible library that lets you use Python's own type hints to define what your data should look like. You basically create a clear, explicit blueprint for your data structures, and Pydantic becomes the enforcer.
And this comparison just illustrates it perfectly. On the left, with the dictionary, you're just hoping the data is right. You're guessing. Is the ID always a number? Is there always a name? Who knows? But on the right, with the Pydantic class, it's a contract. It's a guarantee. You've declared ID must be an integer and name must be a string. If you try to create a user with the wrong data, Pydantic will yell at you immediately, not later. It turns data validation from a hope into a certainty.
And the benefits of this are just huge. You slash the number of runtime errors, you get data validation for free, your code editor like VS Code suddenly gives you amazing auto-completion because it knows the exact shape of your data, and maybe best of all, your code basically documents itself. It's a massive win all around.
All right, so we've tamed our data, we've clarified our code. Now for the main event. Let's talk about making those really heavy number-crunching parts of our AI models absolutely fly.
Let's just be honest with ourselves for a second. The standard Python for loop, it's slow. It's notoriously slow when it comes to heavy numerical work. Anytime you're implementing a custom algorithm or a complex simulation, that for loop is almost always the single biggest performance killer in your entire project. So what's the fix? It's a library called NumPy. NumPy is a just-in-time or JIT compiler.
And what that means is it looks at your Python function and, right before it runs, it translates it on the fly into super optimized machine code. We're talking the kind of speed you'd expect from languages like C or Fortran, but you never have to leave the comfort of Python.
And here's the part that feels like actual magic. You don't have to rewrite your function. You don't have to learn a new language. All you have to do is add one simple little decorator, @JIT, right above your slow number crunching function. That is it.
And the result of that one line of code? It's not a small improvement. We are not talking 10% or 20% faster. We are talking orders of magnitude. It is completely normal to see a function speed up by 50 or even more than 100 times. This is literally the difference between an experiment taking all day to run versus just a few minutes. It's insane. I mean, this chart just says it all, doesn't it? The difference is staggering. Look at that blue bar, 2,000 milliseconds for standard Python, and then look at the NumPy bar, 20 milliseconds. It's not even close. You're watching that performance bottleneck just vanish into thin air.
So, okay, we've covered 3 incredibly powerful tools, but this is about more than just installing a few new libraries. It's about fundamentally changing our mindset and adopting a new philosophy for how we build powerful, robust AI systems.
So here's the workflow you can take away and start using today. Step 1. Be a detective. Identify the true bottleneck. Is it loading data? Is it a specific CPU-bound calculation? Or is the problem simply that the code is too confusing to maintain? Step 2. Once you know the problem, pick the right specialist tool for that exact job. And step 3, and this is so important, always write for humans first. Remember, clarity isn't some nice-to-have luxury, it's a core feature of good code.
And that really gets to the heart of it. The best, most effective Python code for AI isn't about writing some clever, unreadable one-liner that you found on the internet. It's about making deliberate, intelligent choices. It's about finding the bottleneck and then using the right specialized tool to eliminate it.
So I'm going to leave you with this question to think about. Imagine a world where sluggish data, confusing code, and slow algorithms are no longer holding you back. When your tools are no longer the limit, what amazing things are you going to build? What new boundaries will you push? Thanks for watching.